The first part up here is common logarithms. Okay, when we talk about common logarithms, it means like the most common one. Okay, we've talked about a couple things with logs. We talked about earthquakes. We talked about the decibel scale. Each time we made a jump, what did we multiply by? 10. We went 10 times, and then 100 times, and 1,000 times more powerful. That's the most common thing. Okay, that's the most common log problem that we use. So that's why we call it the common logarithm. Here's what we do. If you just saw log of x, what are we missing there? We're missing the base, right? There's not a number. If there's not a number there, it's because, well, we use this one so often that we just don't even need to write it, because if there's not a number there, you're going to assume that it's a 10. Okay, if there's not a number down below for the base, you're going to say, oh, it's 10. Okay? So we're going to always assume it's a 10. It's like if I had a square root sign here. If I had a square root sign, and normally we could have like a root in front, like a 3 or something like that. If there wasn't a number in front of the square root sign, what number would you assume is there? A 2. It's a square root. So if there's not a number there, it would be a 2. You don't have to write the 2, but that's what's there. Same thing with the logs. If there's not a number, it's a 10. Questions with that? Okay, next thing we're going to talk about is Euler's number. Yes, it looks like Euler. It's not. It's Euler. Okay, he's a mathematician. What's pi when we talk about pi? 3.14. Yeah, I know what you're saying. 3.14. 3.14 is pi. It always, anytime you see the little pi symbol, it means 3.14. That is something that exists in nature. Every circle, you can find the circumference and the diameter, or not diameter, but the rest of the stuff with 3.14. Okay, it's not made up. It's actually there. The same thing is true with this E. Okay, it's called Euler's number. Just like pi, it represents a number. When we see E, it's going to represent 2.71. You will never need to say it's 2.71. Okay, you're never going to replace it. All right, you'll just see it and know that, hey, it means a number. This is actually really important. You ever seen a TV show where they find some old bones and they're like, oh, these bones are 300 years old and things like that? Yes. Dinosaur bones, you ever realize how they figure out how old dinosaur bones are? Okay, the way they do that is they use a math equation that has E in it. It's a real thing. It's in nature. Okay, things decompose at a rate of E. Okay, it's something that actually exists. Don't get too much into it. Just know that's what it is. Okay? The other thing we're going to talk about real quick is natural logarithms. Natural logarithms. It says the logarithm of a natural logarithm, what we're going to use is ln. To say natural logarithm, we're going to use ln. Yes, it's backwards. It should be nl. It's not. It's ln. ln means log base e. If you see ln, it's just like log with a base of e. They mean the same thing. Okay? So 3 facts we just covered. If you just see log, it means there's a 10 with it too. Okay, E is a number like pi, and ln means log base e. Those are the 3 facts I just went over. Okay, lots of different stuff going on there, but that's all you need to know.